Live. All right. So I want to introduce everyone to Stephen Robinson, who has been an entrepreneur in a variety of sorts for quite some time, has some great technical prowess, and inspired by the events and various projects online related to respirators, has a prototype DIY respirator that he's using to learn as a proof of concept. So I'm going to let him present, and then if he runs out of things to say, I'll ask him a few questions, interview style. But Stephen, why don't you walk people both online now and who'll be watching the video through your project and your process for getting to it.
Okay, well, nice to see everybody, and have a little time to tell you a little bit about this project that I got myself into a few weeks ago. Maybe replay back to that time, you're starting to see the growth of people contracting COVID, the condition related to the coronavirus, obviously, in Italy, and seeing the growth of numbers there and the risk that they were running out of ventilators, which led me to just start having a look to see what options there are for ventilators out there. And being somebody who likes to build things, I was kind of in the back of my mind thinking, are there components that, an individual could build that were off the shelf, that were relatively inexpensive and available to potentially meet a gap in that space? So I found a design that was being created maybe about 10 years ago. The guy said he unfortunately threw it out like last year at the end of the year, his original design. And I thought, hey, maybe I'll just buy some components and see if I can create something similar to that, be able to upgrade many of the components there and start to see if I could learn some lessons, find out information about how something like this would operate or not. Because when you're building something, doesn't matter whether it's hardware engineering and software engineering, there's always those iterations that you need as you experience how something works. Just to design some things from, in a one-hit go is just not realistic expectation. So even if it was not some kind of final medical compliant application thing that I was building, I felt like it could be useful for me to just have a go doing that and start to learn about it. And maybe, personally, some people maybe make quilts or something if they're nervous. Maybe Steve Robinson likes to build things if he gets nervous. So maybe this is like part of that, right? My background is in control systems, electrical engineering, electronics, and software development. So I run Eastrock Software, and we build applications for companies in data science, machine learning, but also Ruby on Rails applications, and also React applications and Node applications, as well as many of the technologies. But I've always been very interested in hardware, software, and this kind of project is something that's very appealing. First thing I would say about this is not medical grade equipment. I'm not intending for anybody to get hooked up to this. It has lots of limitations, which would mean that it should and would not be used. So I very clearly want to state that I do say you should not use this, right? This is not something that you should use. That said, what I would say is that the UK Chamber of Commerce listed a specification of the things that would need to be solved in order for basically like features, ventilating system, would need to satisfy in order for it to be something that would pass their compliance, which is obviously totally different from the US compliance. But it gives you a trajectory on which you can move towards. What I did do is also a part of building this, and I will demo it soon, so don't worry, hang on in there if you're getting bored with all the talk. What I did do is put on GitHub all of the things that I'd learned about this so far, and just sort of listed out the hardware, the electronics and the very basic code that's in there right now, in order that people could potentially use that as a starting point, a learning point, if they want to. And I also was requested by somebody on Slack channel called Helpful Engineering, where they're pulling together different projects that they can move forward with, a list of these things, which are requirements to pass that UK Chambers of Commerce for a ventilator. If you want the GitHub link for it, I could maybe what I should do would be put a link to that in the chat here. It's also on the whiteboard if you can peer through the gloom there. There you go. But that has some more details. That's all the details so far, of the project. Okay, cool. So has anyone got any more questions? Because if not, I can walk you through the thing, and then I can switch it on, and you can see it a little in action.
Yeah. So why don't you walk through it, Stephen, and then I'll do some questions up front, and then we'll open it to the audience if that works for you.
Yeah. Okay. Cool. Should I hold the demo for the end, or show me to show them like?
I think jump in.
All right. Okay. Let's fire it up. Okay. Well, it's basically powered by 12-volt power supply hiding down there. So it could be fired off a car battery if need be. That basically, maybe I'll just talk you through the actual pieces of it for that, unless I break something here. Yeah, probably I'm going to break something if I'm not careful. But let me fire it up. There you go. Takes out a sequence. Okay, cool. Let's. So what I've got here is this orange hose is connected to this highly medically compliant joke. That's not medically compliant air compressor back there. That's for testing. Obviously, something like this would need to have an actual clean air mixture, and you'd also want to put in oxygen here as well. But that supplies the pressure to this first of 3 valves here. If I just hold that up, you can see. Basically, there's the air intake valve here, and this is slightly wobbly, as you can see, because I didn't have the appropriate screws to hold this down. So that's just how it is. The intake valve comes in here. This basically inflates a set of bags here. The bags that I selected are actually air wedge bags. Oh, here we go. And now I've got to let someone else in here. Miles. Okay, so for Miles's sake, just joined. We were pretty close to doing the demo of it. So basically, here's the design. It has intake valve here, which basically fills this bag back here that's underneath here. The bag itself is basically, I sourced an air wedge, which is something that they use to break into cars, which is a very durable bag, which is low cost and can handle a lot of pressure. Not necessarily because you need a lot of pressure, but that gives you that engineering headroom in which to have more reliability. The bag is basically compressed down with these bungee cords, but you could use weights and mass. This obviously changes the characteristic of the pressure output, because as the bands contract, they will decrease the pressure. So those are things that could be explored. Anyway, after this one's fired, this valve here will then release the pressure to this side, which would be the patient side, and then the exhaust gets exhausted back through there. These valves are controlled by basically Darlington power transistor pairs down here, which are connected to a low-cost Arduino sensor. Also, other sensors in this initial version include reed switches on the side here. Reed switches are switches which activate when a magnet is in close contact with them. And that enables the system to then determine at what position this is open and closed. So it can use that as part of the sort of the loop in controlling this. So I think maybe the good thing to do would be to actually fire it up. So let's see, can we see it? Yes, okay, so let's just fire it up. So you can see that what's happening here is basically on there'll be an intake stroke that goes here, which feeds these two basic air wedges, let's call it, that creates the pressure. These bungee cords, which you could vary, I mean, super basic, right? Create the pressure and tension that pushes through to this. This fills up with a certain volume, the lung, right? And then that is basically pushed out through here. The way I've set it up is that this is closed and this is venting even whilst a new intake stroke goes in there. So, you know, the basic circuit diagram here is pretty super simple. I mean, if you want to have a quick talk through that, we have 12 volts that gets to 5 volts for the Arduino. The reason why you don't necessarily put 12 volts into the Arduino, which it could take, is that this creates decoupling if there was any voltage bouncing that happened here due to solenoids being switched on and off. So this creates a nice smooth 5 volts, which powers the Arduino here. Also, there's a couple of capacitors across that just to decrease any other transients. But then here, you basically have these three are configured to outputs that then control these power transistors. These are Darlington pairs, which then drive the solenoid across the 12 volts. And then here we have the simple reed switches coming in. And things that you could do to improve something like this, there's a long list, and you'll see on that GitHub repo, there's information around that. But if you wanted, for example, in part of the specs for the UK Chamber of Commerce include changing the swept volume that would be provided back here, that could be done by having a variable potentiometer instead of these reed switches, so that you could then track the actual volume that had been swept in this charging stroke, and you could then have the Arduino control that. And it'd be very simple to drive that into an analog input, and it would be also simple to have other analog inputs that could be dials and controls that would be in here. Also, some other pieces of things which would be important to add to this design. So these devices here, this is basically an air filter. It's a N95 filter, which is in line. Typically what you would want is this to be in part of the input line, but you'd also want that to be part of the exhaust line in order to prevent particulates charged with potential virus coming out of the exit of the device. Also, other things that are, goodie bag, right? Everybody needs a goodie bag. This is Steve's Christmas goodie bag. There are also other components here which can be added in. For example, this device here is relatively inexpensive. It's a differential pressure sensor. Let me kind of get that for you. Differential pressure sensor. So you could use that, one of these, whilst you were monitoring the different pressures between the areas of this. So you could, for example, have an overpressure warning, or you could also incorporate the ability to alert with a fail-safe mode that the device is either out of air or not functioning for whatever reason. And depending on the level of resilience that you want, you could have separate circuits which were providing the operational capability and the monitoring capability. That's sort of a few areas of that. Just to say these Arduino chips are extremely expensive devices. You can and very prevalent. I mean, that's an example of one. $10. So very. So I mean, that sort of wraps up probably the most of the design. Just to recap, this is quite open control at the moment. The source code is on the GitHub repo if you want to have a look at that. It's very basic. It's just the first go of that. And it doesn't have some of those additional sensor capabilities. Really, the monitoring here is points to make is these particular valves are quarter-inch valves and allow a certain amount of throughput of pressure. I think on the inside, in the intake side, that's actually reasonable size of valve. The question might be more on the exhausting side of the ventilator. You may want a greater flow rate. So for something like that, things to experiment would be with larger bore capable solenoids. So those are a few of the goodies that I have here for sort of next steps in an iteration of this. Just to wrap up, though, I want to be very clear. This is not medical grade device. I'm not pitching as that. I'm saying you absolutely shouldn't use this because it could be very dangerous. What you see to be added. And I want to be just very clear that that's what this project is for informational purposes. But I think it could provide potentially a lot of information on that. And that's the working side of it. There's another set of questions around, is this particular attempt at providing a ventilator solution the right kind of project to be pushing forward? And then I think, you open the floor to lots of different ways of going about it, whether it's a 3D printing, whether it's sourcing, whether it's getting sort of off the shelf parts that could be individually made by makers and so forth. It's its own job keeping track and researching all of those projects to see which ones could be fertile seeds on the right ground. But my hope is exploring this and seeing what can and cannot work can provide input to a community to help them start to evaluate some of those concepts.
Great. Well, that's a fantastic introduction, Stephen. As far as questions from the group, the preference is to start by just typing them into the chat.
Okay.
We'll address those first, and then we'll go to voice as we move along. So one of my questions to start us off is, now that there have been other ventilator projects that have been emerging, and there's been a lot of attention to this, do you see features that are being addressed by these other ones that you really wish were considered upfront, or they address different problems than what this one would address in a hypothetical scenario?
So, the first thing I would say is I haven't had the time, unfortunately, to do a kind of review of those different designs. So I can sort of tell you a little bit about what I think. I think from what I've seen, there are designs that basically have their own air supply, right? This design requires an external air supply, but there are many other designs there where you have some bag which is constricted and then not constricted and so forth, but still made out of off-the-shelf components. I think those kind of designs have the advantage you don't need this extra hookup, right? Which could potentially be a problem. It's another piece of equipment that you need in order to make something like this work. And I think there's other talk about 3D printed devices, and then you've got a question about, can you source the feed, adequately? How fast does it make? How fast would it take to make one of those products, and how many printers are there, and so forth. But you also have supply problems with something like this. I think if you do look at the GitHub repo, there is, and this is a list I copied from the UK Chamber of Commerce, which is basically a great spec, a requirements document, you might say, for something like this. So, I think as people look at all of these different devices, that's a great feature dot set to be evaluating. And a lot of that, there's obviously reliability components to that, different setting of air volume, just to go over a few of these things, ability to mix oxygen in, be able to adjust the breathing rate to deliver a certain quantity of air, be built from O2 safe components. So, these valves here, these are aluminium, depending on where you come from. But that O2 safe would be something with brass fittings, so that you can't have an inadvertent spark could trigger a fire. So I'm sure there's a lot of aspects to that. Be able to have hookups to various oxygen supplies, be easy to plug in to that environment, and also have some fail-safe characteristics. So,
did you want me to read off the? So we have one. So it's not adding oxygen to the air in this current version.
Correct. Correct. Yeah. Absolutely.
And then Miles asked, who is the user for this? Is it distributed manufacturing or for medical professional use? And I think that's the hypothetical user that if this project evolves, or eventual home use. So would you, and how would you test such a device? And
yeah, great
help with the supply chain? Yeah.
So let's go through those, right? So who is the user for this? It's a great question, right? And I'm kind of feeling out what would be the right answer for that. I think if you took this device and let's say you enabled it to go through all of those steps that are listed out in that GitHub, and you could satisfy those, right? So version 3 of this, if this is version 1, right? So maybe there's a couple of intermediate stages, and you do that. This device would still need to have a connector to intubate into a patient. So that's something I have not talked about here, right? So what happens at this stage, right? Typically what happens in these patients is they intubate them. That is that they put a device, an endothelial tube, which is called, is down with and it needs to be carefully controlled in ER setting, where basically the tube is put down through the body, not directed into the stomach, but through into your lungs. At the end of that tube, they have a bladder that expands. I feel like if I could draw better, maybe I'd have a go up here, right? But basically, let's say you have the patient's mouth here, and then this goes to the stomach, and down here, this goes to the lungs, right?
You're right on the edge of the screen, so you might have to re-aim.
Okay. Boom. Sorry, the wobbles. Okay, so basically, let's say you've got the patient's over here, right? It's not exactly how it all works, obviously, but you've got a stomach there, and you've got the lungs down here, and you've got their mouth here, right? Badly drawn mouth, whatever. Hey, I feel like I should draw a better mouth. Anyway, down here, you've got the patient. You need to put a tube down here into the lungs, and down here you'd have a bladder that is inflated, which then holds it in place. And that's called intubation. And then you would have this tube, which then would be connected to a ventilator. So ventilators require a patient to be intubated before they can be effectively used. This process here is apparently, I speak as a non-medical professional providing just information, somebody that I read online, right? This can be done by a nurse, doesn't have to be by a doctor. But this
in California, paramedics can do it.
Okay, paramedics can do this, right? So this is something which is, if you have the device, is reasonably doable by people. Apparently this process is potentially the most dangerous with this particular virus because it creates a high likelihood of aerosolization of particles, which can be heavily laden with the virus. So the people that are doing this are actually in the most danger. People that are in the ICUs, which is post-intubation, actually it's a safer place for a medical professional to work. But this needs to be the case in order for something like this to be able to properly administer the flow. So with that said, it then indicates that this isn't something for like, you just hook this up as home use, right? So a device, a version 3 of this device that was all compliant and everybody was happy that it could be used, would be something that would help relieve that shortage, which we don't know what that shortage is going to be, even in advanced countries like the US or the UK, which has access to vast production, manufacturing, and medical resources. The concern is, you've got places like the US and the UK. I don't see this being something that you hook yourself up to if you're at home and you can't get through to the doctor. It's more like devices like this would be in the ICU, taking overflow from certified devices when you've gone beyond splitters. So I think you'd have to think about the different levels, right? So you'd have official ventilators, splitting devices, which could split off to have multiple people using one. Then if you reach the limits of that, you'd be looking, what are the solutions have we got? And something like this as a version 3 would be maybe something you would consider in a society that was at that level where you otherwise have people just expiring in a corridor. That's in the US or the UK. Take this to somewhere like Argentina. So I know somebody in Argentina. They live in a town where there's 100,000 individuals and they have 30 ventilators. Good luck getting a new ventilator there. How hard's that, right? So, and that's just one town in Argentina. Think about all those other locations. So I think it's in that context that you've got to look at how can people in a more decentralized way come up with equipment that could help meet that emergency gap in extremis, in extreme times, right? So, I think the question is who would use it, and it's sort of what situation and what country would be the factors around that.
I have a question.
Yeah.
It's my understanding that because of the coating on the inside of the lungs, due to the irritation of the lungs, the patient loses their ability to absorb oxygen. So the goal then is to get air in there with a lot more oxygen in it, so they got a better chance of getting some of it. But I didn't ever hear that it paralyzed their solar plexus or their chest muscles. Seems to me they're still able to attempt to inflate and deflate their lungs on their own. This machine seems to force air. In other words, if they were to lose their control of their muscles, this machine would breathe for them. Is the COVID-19 require that kind of a treatment, or does it just require putting air into the lungs that have a lot more oxygen to it? Like with this device. Let's see if you can see this. This is my Cpap machine. This little guy can blow up my lungs. If I set the settings right, I take a slight little breath and I get a big, it won't blow them up, I'm still alive, but it'll force air and I can control that pressure. There's an atmospheric pressure setting on this. This will just fill my lungs with air. And then when I want to exhale, it senses it and it lets my whole muscles contract and everything goes out. If I was going to be in bed, I'm at 76 years old. If I get this sickness, I need this. If ever I'm unconscious, I want this on my head because this makes breathing wonderful. I tried sleeping without this at times. It's like torture. But all we got to do is add oxygen to this thing. And these are ubiquitous. They're all over. And all the people who are subjected to the threat of this virus, the 76-year-olds, most of them got these machines already. So why don't we just put a device on here that injects oxygen into this? And we got all the control mechanisms there. All we got to do is meter the oxygen flow. Has anyone tried that out?
So what I would say to that is gradations of a patient's state, and it's very likely that a lot of people with that device could survive through their experience with this disease. That said, just from observation of what medical professionals are talking about out there, they use intubation and they use ventilators, and they're not using those. So my sort of gut would be there's a level beyond the needs of that device that can't be provided by that device to a certain set of patients. And hence you have ICUs which require ventilators rather than something which doesn't have this tube. Now, I think success, you should always proceed in that kind of manner. I'm not a medical doctor, so is just one guy's opinion, right? Which means nothing. But I would imagine that there's some point that if you took a distribution of people, maybe it's that you can say just fine. Actually, these people are just fine at home, right? They can just fine at home. These people don't even know they had it, right? They're just completely unaware. Over here, there's a set of people that could use this Cpap technique, right, to survive. But then there's some area here, which, because of the large numbers, will be substantive, that requires more invasive treatment. So I'm not dismissing this in any way whatsoever, and I think that's a great idea. But it would seem to be that there is a need for more invasive techniques.
Your point is well taken. What I would like to have as definitive answer from a medical expert is these people who are in the last stages just before they die, do they lose their ability to breathe? Their muscles don't work anymore, or is it just that their muscles are working, but they're not getting any air into their bloodstream?
The one thing I have read is that that as a patient gets further progressed in their inability to take in oxygen through their lungs, they end up having to work harder and harder to do that. And there's just a physical exertion that these people are basically putting, their body is going through like a marathon runner, and they just can't keep that up. And so then their muscles, it's not an inability to control the muscle, it's just an exhaustion. And that at some point they go beyond that exhaustion, they can't provide that self-mechanical activity to maintain oxygen flow. And then when that happens, they go downhill rapidly. They have a lot of organ failure quickly because they are just out of oxygen and out of time. And that a technique with intubation and supplying forced air in concert with higher levels of oxygen in order to give them the best chance of absorbing that oxygen through this lung membrane, which has become inefficient through to viral damage, enables them to endure that for a period of time, enough so that they can fight off the virus to become capable, and then they can be taken back off. And I believe there's a lot of procedures around taking people off a ventilator so they don't get dependent on the ventilator as well. So it's a complex process. Before building this thing, I sort of thought, hey, you just create a ventilator, you hook yourself up, and you suck on it like a tube, kind of like what you've got, right? But as I read more, I was like, wow, that seems like this is a very complicated and medically involved, process where the ventilator is just one tool and part of that.
Oh, I will stop. I'll stop.
Yeah.
Just with this one last comment. The Cpap machine will definitely force your lungs full of air. I mean, you'll feel them blow up. You won't even be breathing. It'll just, if you set the pressure high enough, it'll blow up your lungs for you. All right, enough.
Cool.
So, questions from other folks?
So I could fire through these questions quickly so we don't.
Sure.
How do you test such a device? I think you would want to have this. Another question from Miles. Basically, you could have manometers, which are basically simple pressure tubes. I mean, you could basically create a tube and look at the measurement of water in the differential measurement of the water in that column, and that will give you very accurate information around the pressures in the various stages. So I think you could start doing that. You'd also test it by running it for long periods of time, and then also probably interfering with the power supply to try and create brownouts and effects like this. So I think there's lots of good ways you could do tests like that. Do you want help with the supply chain work? So, I mean, I think that's a big piece of it. Something like this, which depends on supply chains. As of yesterday, the components to buy this are now basically like almost 3 weeks out, whereas like last week you could get these delivered like within a couple of days. Now that's through Amazon, okay? So but that's the supply chain, right? That's our default supply chain. You then switch to other supply chain. If you look at other people that provide the valves, which I could imagine being one of the pieces which runs out quickly, they themselves, if you go to their website, start posting information about, because of lockdown and so forth, they're having troubles with their supply chain. I'm sure if they were designated to be vital, they would be freed up from that, but you could imagine there's an unclogging problem that still has to happen, which you wouldn't necessarily have 3D printing. Someone else could review the other open source projects, would be wonderful. The COVID patient can absorb oxygen, but his chest and diaphragm muscles still work.
That was what Rick was asking. So that
okay, gotcha. Yeah, we're answering that.
Covered. Yeah. Great. So, are there any other questions from folks voice-wise? Otherwise, I'm going to a wrap-up question, and then we can kind of break formal activities. So Stephen, I think you had a pitch, where you talked with others who were working on projects last night, and we were able to talk with somebody from Yale New Haven Hospital, and one of the people in the group had said that they were skeptical of this ever coming into play in our modern society, and the representative didn't say we will need them, but said there have been cases where people have been taken off of ventilators, and had there been any option into that hospital, even if it wasn't medically, up to the standards we'd usually want to see, that they would be appreciative of options becoming available. So to me, that indicated that something that at first glance seems like a very, might be seen as outlandish, there are, real practical changes that are possible that may make us wish we'd invested the time and energy to explore these options. So, having come out of that experience, that conversation, do you have thoughts on what are the next steps in advancing this? What resources that you need in general, or what parts you would like to hand off, or knowledge you would like to share to better prepare us in the hopefully unlikely scenario where there's folks looking at terrible alternatives and looking for the next best option?
Yeah, I think her point was well made, and it made me sort of think of this project as sort of almost like a very poor insurance policy in some sense, right? So it's like, or I don't know, maybe that's the bad way of looking at it, but I think you want to exhaust absolutely all of the possibilities, but when they're all exhausted, you would want something rather than nothing, would be what I would want if I was the patient, right? So to that extent, I think exploring something like this has value, and absolutely let's hope nothing like this actually is needed, right? That's what our hope would be. I think to advance something like this requires time, effort, tools, and basically time and resources to advance this, right? I have a certain amount of time that I can devote to a project like this, just due to all of the other things that I have that I'm pushing forward, that I have to push forward, as a parent, as somebody who's breadwinner with clients and things like that through a tough time like this. So there's a certain amount that I can push this forward, but it would be great if there were other people, that this project was, of interest to them, and they thought, hey, I feel that I have the right time, or I have the right setup to try and push this forward. I think this is something where I see, a role like myself could be help give feedback, help come up with sort of directions of it, suggestions around different things to sort of push it forward. Now that may be, so what would that look like? It could look like, for example, if someone said, you see, MakeHaven's probably all shut down, but like if it was like, hey, Steve, could you drop this off at MakeHaven, and we'll use this as a prototype, and give us any of the valves and things that you've got, because it's hard to source, and we're going to start to try and tool up and build it, and maybe build pieces of it, or try and try and work through those line items that you were provided by that helpful engineering, I would say I'd spray it with Lysol and whatnot. I'd say that would be great, and maybe that could be a way to go forward. Or if someone else had the components and they could keep advancing it, I think something like that would be potentially a very interesting way to keep carrying this relay pole or banner or torch, whatever your analogy is, forward.
Yes. Well, I think there is a lot of interest, and there's a lot of energy right now going into some immediate efforts for making masks and other preventative measures. But my sense from that meeting and from conversations since is that there quickly is going to be growing interest in these sorts of projects. So I hope we'll find ways that we can safely engage the community in helping to provide a distributed solution where we can collaborate and, of course, work with other communities that are looking at the same problem. So I applaud you for your initiative here to get started, and I think you're right in looking for how we can share the load.
Yeah, and just to follow up on that, it's I've tried to document as much of this as I can on that GitHub repo, which I sent a link to up here if you can decipher it, in order to help the conversation, right? And if somebody was out there who said, hey, I love all of that stuff, and I've got some time and I can work on it, and if they were local, I'd be happy to drive the thing over. I'm in pretty much kind of quarantine, so I think I don't have anything, but who knows, right? But I spray it with Lysol and hand it over and chat with them over Skype about what we could do to take it forward. As I say, I've got some more components here that could be evaluated with solenoids and which may either increase the capacity and other aspects that I was talking about before. But I go to that GitHub and see that. I'd also say this is just one project in many different attempts to do this. I want to be clear that I'm not saying that this is the right approach, right? I think maybe that you evaluate this versus other things and you say, yeah, I'd rather put my money on some bag in a box that gets squeezed, Maybe that's the right way to go. But it's here if people are interested.
Well, amazing. And thank you for taking the time not only to build the experiment prototype, but to share that knowledge with all of us. And I do hope it fuels a larger conversation within the community. And thank you to Jonathan for jumping in and doing the recording when we had some technical difficulties. So I think we're coming up on the hour. I see there's some chat where folks are responding to the question about the difference between the Cpap and the intubation ventilators. It looks like basically the intubation gives a lot more fine-grained control, and that's why it's used with damaged lungs and that setting. And that's from somebody's spouse who's a ER doctor. So in the chat for folks who want to get to more detail. But I think we'll conclude this conversation here, unless, Stephen, you had any closing comments you wanted to make as we depart.
No, I thank you, JR, for giving a chance to talk about this. And, if it's helpful to anybody, that's great. And, I'm always a big fan of MakeHaven and the work you're doing there and organizing this and bringing people together around all of these things. I think, a little round of applause for you.
Well, thank you for being part of the community.
Could you bring the camera close onto the link you have written on the marker board there?
Absolutely. Right, let's disconnect things.
Just want to be able to get a good view of it for other folks. Okay.
Great.
Is that good?
Perfect. Yeah. Thank you.
All right. Okay, cool.
Great. Well, thank you, Stephen.
Thank you very much.
This will conclude it.